Cool. All right, welcome back, Vapor Central. Thanks for joining us again for the Karma Cup Speaker Series. On stage, we have David Schaefer and Marcus Bubbleman Richardson. They are veterans to the Karma Cup Speaker stage, and they're going to be talking about safe extraction methods. So, all those wonderful cannabis concentrates that you guys enjoy, these guys are the guru of them. So, I'll let you guys take the stage, say a few words.
All right.
Cool.
Okay, here we go, David. This will be fun.
Hey, how's it going, everybody? Marcus Bubbleman Richardson here. Sort of, I guess, kind of representing what is known as, really it's a misnomer, but what is known as the solventless extraction. I call it a misnomer because terpenes are present in most extractions, and they're hydrocarbons, the same as butane and other gases. So there's nothing really solventless about extracting cannabis when you're extracting terpenes, but I guess I'll be kind of on the solventless side of things here. Water extraction, mechanical screen extraction, rosin extraction, and even steam vac distillation for terpene extraction. And I guess you'll be on the other side of things.
Of course, I'll be talking about the solvent side of things, including the dreaded BHO, which is my personal favorite, and representing everything such as CO2 extraction, ethanol extraction, anything that involves a large amount of solvent. As Mark was saying, that the whole process is kind of solvent involved, no matter how you kind of look at it. But I'll be covering those ends, everything from R134A to propane and butane.
Right, and so, a lot of people might think that there's not really any potential dangers in extracting once again, the misnomer solventless. But there is, with water extraction, if you don't clean your machines, there's the real possibility of microbial contamination. A lot of people, use the machines that I've sold them over the years, and they're great for personal use. If you start getting into commercial production with them, they're not really designed to produce, large amounts for the commercial market. They're really a personal unit, and so once you start processing more and more, if you're not opening up the bottom of the machine and cleaning it out pretty much after every run, or at least every day's runs, you really end up with microbials trapped in the water, resin, plant particulate gets trapped inside the motor underneath the unit. And over time, you'll produce some pretty nasty microbials that'll end up contaminating your hash in the long run. So one of the things I've been doing for the last year has been working with a company called Whistler Technologies, and we're designing EU GMP certified stainless steel industrial commercialized water extractors, as well as large-scale dry sifting and rosin production. And so that's pretty important when you're looking at the difference of the markets, mainly for medical and recreational. Recreational, I can't really imagine. In the world that we're in right now of cannabis, everyone's kind of hiding behind the medical. We were all kind of mostly recreational users. Medical came in; it was the most beautiful thing. We all got in behind the shield of medical to hide behind it. But not everyone has the SOPs to really stay at that level of what real medical is. I think a lot of the people in the industry are going to transfer into recreational, and the reason I say that is because, recreational drugs are poison. Tobacco's radioactive, alcohol's poison and kills your liver, and all sorts of the recreational drugs that are available to humans are generally not really what I would consider healthy. Even most of the food people eat isn't organic. Most of the clothes people wear aren't organic. Generally, I meet a lot of people who really want to talk about having the highest quality cannabis when they generally don't do that for any other aspect of their life. It just seems to be this cannabis thing that everyone's really stuck on. And I get it. We inhale it into our lungs, and there's people spraying nasty chemicals on it, which becomes a problem for all of the processes that David and I have just mentioned, whether it's cryoethanol extraction, CO2 extraction, butane, propane, water extraction, mechanical screen separation, steam vac distillation, or rosin. Anytime you have chemicals that have been sprayed on that material, it's not going to be an ideal thing for medical consumption. Perhaps maybe less so for recreational, because just go outside on the street and buy food from any of the vendors or any of the restaurants. 99% of it is not organic. It's all sprayed with chemicals. That's kind of a major thing for us, especially in the solvent world where people think they can clean things up using short path molecular distillation without the understanding that, of course, cannabinoids have a very similar molecular weight as the pesticides that you spray on them. So when you try to run it through the distillation process, you end up concentrating any of the chemicals that are sprayed on there, unless you involve other processes. Generally, so there's a lot of different things to sort of pay attention. I really make a division in between the recreational market, which I see already. There's so many. I mean, look at sugar, like Kit Kats and O. Henry bars. Like those are really not healthy at all. I wouldn't call them like a medical product, and that's unfortunately kind of how I see cannabis falling on the recreational side. I don't think that it's going to be organic. I don't think, well, even now, how many LPs sell organic herb? How many of the dispensaries that you go and buy cannabis at will pass microbial and pesticide testing if you actually took them to a lab to have them tested? So you often have a strong division between the legal licensed production facilities here in Canada and the dispensary models. I think there's good in both, personally, but I think it's generally like a small percentage that you actually see, good organic, clean meds available.
Yeah, 100%. It's also really interesting. We're dealing with full whole plant extraction here, where if you look in pharmaceuticals anywhere else, it's not exactly what you're getting in that tiny little. Any medicine should be exactly dosed and easy to consume. That's why pills are actually really popular in the medical world, just because of easy delivery. So it's a whole new era for pharmaceuticals to be kind of looked at where there's a medical plant, but it's the whole entourage effect of the whole plant that's actually making it have those actual medicinal properties. So you see a lot of pharmaceutical companies where a lot of the solvent extraction actually comes from this pharmaceutical world. So it is actually on the medical side. It is actually already approved. It is actually already used. The reason why you see giant CO2 extraction facilities and you see all the CO2 extraction technology, and that's 100% from the pharmaceutical industry. And they've been coming into the industry and trying to apply their same philosophies, same extraction methods, but they're hitting challenges because the whole cannabis plant is really what creates that whole entourage effect. So there's this whole interesting divide now where it's like, well, we want to maintain as much as the plant material as possible, but a lot of the methods and the pharmaceutical SOPs are quite the opposite. They're about precision extraction. They're about reducing things to only a few elements, if not just one, and then bringing them back together to create that pharmaceutical, medical drug, if you will.
Yeah, and what I would add to that too is that you have to keep in mind that cannabis is a phytoremediative plant. So one of the projects that that I was involved with back in the 90s when we were doing hemp cultivation in Manitoba, my friends and I got hemp growing in Manitoba for the first time in 73 years through some activism and approaching our Minister of Finance and Agriculture. And you may have heard of a project in Chernobyl where they were using cannabis plants as phytoremediation to remove radioactive nucleotides out of the soil. That was started by our group, Consolidated Growers and Processors. And this was found out accidentally, actually, from one of Canada's first hemp farmers, Joe Strobel. He was growing on a tobacco field, which they spray radium-226, which is a radioactive nucleotide. It's why tobacco is radioactive, actually. And so it raises the nicotine levels naturally on the field, which is pretty, like they're not allowed to do it in a lab. So radium-226 plays an important part in producing the addictive qualities of tobacco, and that's why they spray it. And when you burn it, it turns into polonium-210 and lead-210, and half-lives of thousands of years. All they do is mutate healthy DNA. Really, really nasty stuff. Because of it, the tobacco farmers have to measure the radiation levels of their fields after each crop. And when they had grown their first experimental hemp crop in 1994, this was here in Ontario, when they measured the field, it had like a like a substantially lower radiation levels, and they were baffled by it until someone figured out to test the hemp, and of course the hemp had absorbed all of these things out of the soil. For those of you that aren't familiar with phytoremediation, it's plants that, there's sunflowers that can absorb nickel, so it's a way of mining. If you find a rich deposit of nickel, you can plant sunflowers all over that mountainside and basically down the sunflowers to collect the nickel that the plant has pulled up into its system. So cannabis is very much a phytoremediative plant, and it will pull nasty things out of the soil. So this becomes an important factor in understanding when you're growing cannabis as a medicine, that you should really be aware of the quality of the soil that you're growing that cannabis on. This becomes a pretty important factor. And getting back to what Dave was saying about pharmaceutical companies, I'm quite sure it's probably one of the reasons why they're more interested in producing. Oh, there's a couple of reasons. It's one of the reasons. Another reason would be the accurate dosage. So certain people work great with whole plant profiles, and other people, more sensitive people, things like Crohn's disease, things like Dravet syndrome, some of the really touchy epileptic diseases, they require very accurate dosing. So, there's going to be a place for monomolecular medicines, CBD, THCA, isolates removed from oils that have either been extracted with BHO or CO2 or cryoethanol, and then taking that and turning it into distillate, which is basically decarboxylating it and removing the terpene content and concentrating the cannabinoid content into the high 90s. And then from there, there's crystal chromatography and other processes that you can actually crystallize the cannabinoids out of the solution. And then you have these monomolecular medicines, which the pharmaceutical companies are much more stoked on, because they can create formulations with those medicines, and those medicines can stay accurate to like the nanogram every single time, which, maybe if you're a puffer that loves the entourage effect and loves the full terpenes, and that's not for you, but you certainly wouldn't want to be an activist against that, because maybe some 5-year-old kid somewhere with Dravet syndrome who, if the cannabinoid profile changes the slightest bit, if the terpene profile changes the slightest bit, if there are chemicals in the soil that the plant has absorbed up, these are going to have a very detrimental effect on that end user. So I always sort of promote people to look at cannabis as a quiver. There's no one arrow better than the other. It's just the arrow that you prefer in that moment that you want to pull out of your quiver. But I'm certainly not interested in having 1 or 2 arrows in my quiver when it comes to cannabis. I prefer to have 50 to 100.
Yeah, absolutely. And with the solvent extraction, back to safe extraction a little bit, the downsides to most solvents is their volatility and creating an explosive situation, which is in the case of butane and propane. All these things can be easily avoided with the proper equipment, training, and education overall. One of the things we've been doing is training everyone from our end users and the operators to first responders to anyone that's involved from the code inspectors. I've spent a lot of time working with fire departments in the last 2 years, bringing everyone up on to speed as especially in the U.S., we move towards legalization and licensing. There are definitely downsides to it, as far as having solvents left over, using dirty solvents. That's probably one of the biggest ones people don't talk about, is how clean your solvent that you're using is. Just like Mark was saying earlier, with the water, you have to make sure everything is perfectly clean, even the water itself. Same goes with, cryoethanol extraction, the CO2, the hydrocarbons. Starting off with that clean product, that clean solvent to begin with, the clean plant material is the most important fact. You can't start anywhere else but there. Once that's taken care of, doing the actual process safely is the biggest issue with solvent extraction. Education is the number one key. Even in non-cannabis extraction scenarios, hydrocarbons are used in our everyday lives. On an extreme level, it's probably one of the most used gases out of any gas that we have that we use on an everyday basis. Everything from cooking our food, powering our houses, sort of generators going that compress air. Simple things like that that you don't even think of are used on an extremely large scale. To where we have really good data on that. 70% of LPG, LPG is the same as it's butane and propane. There's a whole array of gases that fall in that category, all hydrocarbons. The biggest issue is user error. So 70% of LPG incidents in the United States, at least, are from a lack of education and or training. So on my side of things, that's indefinitely important, and is going to continue to be the most important thing, and has been my personal focus when it comes to safe extraction. So it's not just the extraction process, but it's all the SOPs, anyone who's entering the building, anyone who's interacting with it. It's a whole education process that has been going really well, and we've made great strides in the last 5 or 6 years from people using cans of butane, which have all sort of degreasers, anti-rust agents, all this terrible, nasty stuff. Running it through glass tubes into a Pyrex dish and using double boiler systems to evaporate it off, mixing the hydrocarbons with air, creating potentially explosive situations. And as Mark was saying a little bit earlier before, up until solvent extraction, we didn't really see deaths from cannabis manufacturing or even any major injuries. The biggest thing was legalities and being prosecuted for working with the plants. So solvent extraction definitely added in a new element. A lot of it didn't help with the negative stigma against cannabis. But the reason why we do use solvent, because in some situations they're really irreplaceable. Doing crystallization, all sorts of different types of separating processes require solvents. I've actually been working with water as a solvent also in a lot of different ways. But some things can't replace alcohol in certain situations. The hydrocarbon is a nonpolar solvent that leaves all the water behind for the most part, and you can do it with extremely low temperatures and virtually no pressure, giving you the highest and fullest spectrum of terpenes out of any other sort of extraction. So there's all sorts of advantages and disadvantages to each process, and like Mark was saying, I would never want just a couple arrows in my quiver when it comes to cannabis. I feel that all types of extraction have their place, and that's why I've been working so hard to keep solvent extraction in the industry and teaching people and providing the equipment to do it safely, efficiently, and to get rid of that negative stigma and work through it that solvent extraction has really caused the cannabis industry.
I guess I'd go back to one of the points you made in regards to the importance of clean solvents and clean water. These petrochemical companies are brilliant in the way that they can reuse their byproducts of their industry. So the one that's in water, of course, is fluoride, which is a byproduct of the aluminum industry. It's a toxic, it's a neurotoxic. It was classified by the U.S. military as an intellect suppressant, and I'm pretty sure the first time it was ever given to humans when Hitler tried to docilize the Jews before gassing them, at least in his mind, out of existence. And so these companies have ways of releasing these neurotoxins and these absolute poisons into their own products. And so solvents contain all of these different products. In naphtha, they call it rust inhibitor. In butane and propane, they call it ethyl mercaptine. There's all sorts of different names for these compounds, and it's very important, whether you're making water hash, whether you're making solvent-based extracts, that you acquire solvents, whether it be water or petrochemical-based ones, that they are clean, that they do not contain these particular toxins, because they concentrate, they're oil-soluble, they concentrate into your product rather than out, and I think it's kind of the beginning of safe extraction, is to make sure that I don't like to run water hash with fluoride-rich water, and I don't use fluoride ice. I prefer to keep it out of my hash completely. And my friends that use solvent-based extraction processes are much the same way. It was actually a friend, Khalid, who was a big BHO maker. He came on Hash Church. I'm not sure if many of you have ever seen that show, Hash Church, that I do on YouTube. Generally every Sunday. Supposed to be doing it right now, actually, but I'm here. And so,
Thank you for that.
What's that?
Thank you for that.
Yeah, yeah. And so we had Khalid on Hash Church, and he was a butane maker, and he sort of discovered that, there was this contaminated oil. He was the one that dubbed it the mystery oil, whereas if he took the can or container, like a large container, a cylinder of butane, and he sort of distilled it through his unit, he would end up with this oil in the end. He just couldn't figure out what it was, and he took it to a lab, and he tried to get the breakdown on it, and I guess it's like a patented recipe from the petrochemical industry, so it's like you're not really allowed to find out exactly what it is. He couldn't anyway. He went to multiple labs, and then he switched to CO2, and then he found it in the CO2 cylinders too. It was this oil that basically goes from the nozzle to the, like a lubrication oil. At least that's what they claim it is. I'm more of the mentality that I'm not super trusting of petrochemical industries. I believe that you could get gases and clean them up, but I don't believe that you would want to trust them to do that work for you. That just generally from what they're doing to the planet, how that whole industry works, they don't seem to me to be the most the most trustworthy of people, and that's just the case in a lot of instances. Also with water cleanliness, they're constantly trying to put in the water that just shouldn't be there. And if I'm using water to use as an extraction, not as a solvent, but definitely as a carrier, as a transfer chamber, if you will, for water extraction, I'm not sure what your guys' level of understanding of these extraction processes are. We kind of just came in at a high level without really explaining the simplicity of the processes. Maybe you guys want to hear a little bit about how the processes work?
I would like to expand on that mystery oil just a little bit to
Sure.
explain it and why you see it in CO2 and in hydrocarbons and in basically any other gas. A huge reason is because of the pumps that are used to move the gases around. They're all these giant piston-driven pumps.
Mm-hmm.
They all require lubrication, or else the pumps break down themselves. And so that always makes it in just because of the process of moving it around. So Mark is 100% correct. The only way to have a truly clean solvent is to take a raw solvent and to clean it yourself. So there are a few companies out there that are working on scaling up hydrocarbon cleaning processes to where actually go and scrub the gases depending on, or the solvents themselves depending on what they are. But a lot of the entire industrial process that's out there is just not food grade. It's not friendly to human consumption in a lot of ways. So that is a whole other aspect to it, that you're right, you can't trust the solvents from where they come from, and having solvents cleaned post process is really where the magic is going to happen. You can clean the hydrocarbons down to a pharmaceutical grade level. The way that we recover all the hydrocarbons, we can do extremely efficiently and make, that whole process, which is going to be, and is expensive to clean your solvents, being able to reuse them over and over again and also clean them as you use them again is something that has really started to improve the overall quality of and the safety of all solvent extraction. It's in the hydrocarbon industry, we have a pump called the Master Vapor, which is a diaphragm pump, and that's the first pump in our solvent industry that's FDA certified, besides the piston-driven pumps used for CO2, which actually use food-grade grease on them, because all piston-driven pumps are going to need some sort of lubrication and are intrinsically not the cleanest pumps in existence. So there's a lot of improvement, even in the already pharmaceutical-grade industry, that I'm really proud to say that cannabis is coming in and not taking that as a viable end to how safe and how clean you can make the product, and having the correct hardware that's actually food grade and made to process products that are going to be used for human consumption. We're taking these aspects to another level, and we're looking to make the cleanest extraction processes, which actually put companies like Waters, which is the biggest CO2 extraction company that provides most of the superfluid CO2 extractors. When you go into any FDA-approved analytical testing lab, they're 90% of the time using their equipment. All their pumps on their $500,000 CO2 extractors are using a food-grade grease, which I don't know about you, but I don't want food-grade grease in any of my extracts, especially when they're being consumed through vaporization or combustion.
Well, that's the big one. It's not food grade is something that goes into your stomach, and stomachs are built to take a lot, but vaporizing things and inhaling them into your lungs is a very, very, very different situation. I hear people use the argument, well, it's food grade. It's like, yeah, but you're not eating this. You're burning it,
Exactly.
combusting it, vaporizing it, and inhaling it into your lungs. It seems like a little bit of a different
100%.
100%. So, yeah, I don't know. What else?
So you wanted to go into a little bit of the basic process?
Sure. So most of the extraction processes that I'm talking about are to isolate and extract microencapsulated resin glands. So I'm sure most of you are familiar where the medicinal components or recreational components or preventative components, whatever perspective your ego is convincing you that you're coming at this from, which cannabinoids really don't care whether you think it's medical, recreational, or preventative. It just works in your body the way it works. So water and mechanical screen separation and rosin separations are, well, not rosin, but the other two for sure, are microencapsulated resin glands. So water hash is using the benefit that the wax membrane that's holding all of these oils inside the trichome. So just to give you guys a really short little sort of science lesson, you have the trichome head, the glandular trichome head. There are inside that trichome head two different types of organelles, which are called vacuoles and plastids. And inside the vacuoles and plastids are produced phenols and hydrocarbons, so alcohols and terpenes. And those are the building blocks for all of the cannabinoids and all of the terpenes. Those are pushed upwards into the upper membrane of the glandular trichome, and there's a little fibrous mat in there that they settle into, and UVB light cooks down, and first it produces CBG, which is the first cannabinoid that's the precursor to all the other cannabinoids and the entire terpene profile. And so that's all happening in this little almost like lab inside the glandular trichome head. So with water extraction, what we're doing is we're freezing that wax membrane, and when you freeze wax, it becomes brittle. If you looked at a photo of a glandular trichome, it's like a large head sitting on a small stalk, and it's obvious that at the neck of the point of connection where the head joins the is where it becomes the most brittle. And so that's why water hash, the two components of why water hash works. A, the wax membrane gets brittle and freezes, and when we mix the water and the ice mixture with the plant matter, the ice smashes back and forth, and it basically breaks those little heads off of their little plant body prisons that they've been attached to. And due to their density, because they're made of oil, they're still affected by gravity and water, and so it's really why it allows almost anyone with a very little knowledge safely to extract. There's not a lot of education that's needed for water hash. There's not a lot of safety that's needed to be put in place aside from understanding microbials. You can teach anyone to do it in about a half an hour with the right tools. I use my own bubble bags, but there's all sorts of different water extraction kits on the market now since I've come out in '99. And those resin glands sink in the water due to their density, due to the fact that they're still affected by gravity, and everything else floats. So you create this transfer chamber in water where all the plant matter is floating, all the resin glands are sinking, and then of course you're also washing those resin glands. Anything that's on the outside of that head, for the most part, there are certain products like Fender and sulfur, which I really try to tell people, it's not an ideal situation to grow with these products. Glandular trichomes are present from the day the epicaudal pops out of the cotyledon. The cotyledon is the first two set of leaves on a seedling, which are the round leaves. They don't look like cannabis leaves. They're the first set of leaves, but the first set of true cannabis leaves is called the epicotyl. They have serrated leaves, and it comes out from the cotyledon. And if you macroscopically photograph an epicotyl, you'll see that there are glandular trichomes already present. So when you hear people say, well, I don't spray in flower, I only spray in veg, they just don't understanding that there are glandular trichomes for that material to still stick to. And sulfur, I'm sure you would agree, is just a nightmare from all extraction processes. It comes out in the oil, it comes out in the hash, it comes out in dry sift, it comes out in rosin. I've never really found a way to get that out. I'm sure chemistry, there's solvents that you could use that would be multi-stage, and perhaps a PhD in chemistry would be required. But for the most part, it's a big nightmare that I've always sort of promoted people to stay away from.
Yeah, and the human nose is extremely sensitive to tasting sulfur, so it's really easy for us to be our own analytical instruments when it comes to sulfur and other different things that make it into the plant material. You can actually taste it immediately. You can almost even smell it off of the product itself. Everybody understands it's kind of like that rotten egg kind of smell and taste, and you just can't miss it whatsoever. So that brings me to another interesting point, is how powerful our sense of taste and smell as human beings are. For those who don't know, analytics are just different types of solvent extraction. So, a lot of times it's using superfluid CO2 extraction to actually do the analytics to try to see what's actually in the extracts that we're making. But when Mark's using mechanical methods and not damaging terpenes and all different aspects of the plant material, and then you go and use some sort of very intense solvent extraction process to actually try to separate everything to get some analytics on it, you're going to actually destroy a lot of those terpene spectrums and plant materials that you wouldn't, you can't extract those with CO2 or chlorophyll or those other solvents that they're using to do the analytics. We truly don't know what the true terpene spectrums are in plants in general, and you can easily see that by taking a plant material and having it analytically tested and comparing two different strains, and you see a very, very similar terpene spectrum according to the analytics, but when you taste it yourself, you actually taste something that's very, very completely different than what the analytics are telling you. And what that tells me is that we're just at the beginning of being able to even break down the cannabis plant and see the full terpene spectrums and what's actually in it, but we can definitely taste it.
So I was going to take it back as well to, getting into safe extractions. I think, taking it past spraying chemicals and having all these problems, there's a reason why the majority of growers have problems with bugs and infestations and diseases and pathogens and fungi that impregnate their plants. And that's generally that cannabis is one of the last clonally produced plants on the planet that we don't use tissue culture to propagate the plants. So for those of you that have a little or no understanding of tissue culture, there's a couple of different ways to do it. There's the sort of the evil Monsanto way, which is callus tissue culture, where they're doing intercellular tissue culture, taking cells and putting them inside other cells and doing this whole other work that I'm not going to be talking about. I want to talk about micropropagation, meristemic tissue culture, which is basically kind of like microscopic cloning. You're cloning cells out of the meristem, the growth site of the plant, the part that those fresh two leaves are coming out of. And when you run stage 1 of tissue culture is called initiation. And generally what they'll do is they'll cut the meristem and they'll grow it in an agar solution in a test tube. And as they grow it, after a week or a month, they'll cut it again and grow that and cut it again and grow that. And what they're doing is they're cleaning the plant of all of these pathogens, fungi, and bacteria, including intercellular bacteria. And these things occur when we clone and grow and clone and grow and clone and grow. When you clone and put it inside a dome that's 100% humidity, you might have a small leaf on that clone that broke off where you didn't cut it real close with a razor blade to the body of the clone, to the stalk. And those little tiny pieces of plant matter become vectors for pathogen, fungi, and bacterial infestations. And so it's much like people with candida. You know, they might not look like they're dying, they might not look like they have cancer, but they're slower. They're not expressing themselves to their maximum ability, and plants are no different. So when you get a plant where you've probably heard the term from growers, genetic drift. Genetic drift doesn't actually exist. It's really these pathogens and these fungi and these bacteria that have impregnated themselves into the plant, sometimes thousands of them just in that plant, and you're cloning and sharing and cloning and sharing. It's just like it's almost like a venereal disease that everyone's just sharing. Here, you have mine, I'll have yours. Let's just keep doing this. They're growing these super low quality clones, and because these clones are so sick, they might not look sick, but they are sick. And when you're sick, you attract predators. You know, wolves don't hunt the healthy. They hunt the sick and the old and the young. And bugs and pests and diseases and pathogens and viruses are no different. They also hone in on the weak. And so when you're growing plants that are so impregnated with these pathogens and fungi and bacteria, you almost don't have a chance. You're going to get powdery mildew. You're going to attract bugs. And when you get to when you're doing it in a small grow, it's one thing, you can pull it off. But when you're growing hectares, like Driscoll's, the strawberry guys, those guys do 10 billion tissue culture plants a year, 1.9 billion just for California, that they grow in a single lab in Colorado. And initiation is one of the most important factors. Go ahead. Oh, 5 more minutes. Okay.
That was quick.
Yeah, just wanted to give you guys the lowdown on tissue culture because I think it's going to be an incredibly important aspect of both of our focuses. For me as an extractor, I'm building a large, like a 45,000 square foot extraction lab in Vancouver here in the upcoming year. We're specializing in all the solventless extraction processes, but also large-scale cryoethanol and CO2 extraction. And we're already creating relationships with companies like Segra International, which is a tissue culture company out of Vancouver, because the people we want to get to grow for us, we want to make sure that they're acquiring their clones as clean as they can possibly acquire them, and that's going to be through tissue culture.
Yeah, and that's an amazing point. I agree 100%.
Yeah, it's definitely something that if you don't have to, systemic diseases like powdery mildew and viruses and bacteria, they're just sitting in the plant invisible. You don't even know they're there. But if you can, a company like Driscoll's, which Segra is going to be no different, they have a microbiology lab. They spent 2 years and a couple $1 million validating that lab. And so when you give them your genetics, they will initiate them and clean them all up for you and get them ready for mass production. They will put them through their microbiology lab. They will fingerprint the genetics so that when you order 10,000 or 100,000 or 1 million of your plantlets, you're going to get your DNA sequence that came with the plant that you gave them in the first place. So it's assured that that is the plant that you've got. And then you'll also get certification that it's pathogen, fungi, and bacteria free. And I think that's going to be a gargantuous step in the cannabis industry because right now we just have so many pests and so many diseases and so few people. And keep in mind, tissue culture is in every clonally produced plant that you consume, bananas, raspberries, blueberries, almonds, pretty much every one you've ever had, unless you went to an island and picked it wild off a tree, came from a tissue culture. So this is the present for all other plants, and it's only cannabis that is catching up. And I think we'll see this with all sorts of different aspects of cannabis, whether it be agriculturally or pharmaceutically or whatever it is. We're catching up by implementing these different aspects that have already been implemented into these other industries for dozens of years.
Yeah, we like to say never reinvent the wheel. We like to learn from other industries, and that's what's really going to accelerate the expansion and the scalability of cannabis 100%. Not to say that cannabis hasn't been pushing other parts of the industry and improving simple things like rotary evaporators and taking them to a whole different level. I think both big agriculture is going to add a lot to cannabis, and cannabis is going to add just as much back to it. So I'm really excited about the future.
Absolutely. Me as well. I guess that's a wrap.
Yeah, no, awesome. Thanks so much, guys. Marcus Richardson and David Bookard. David Schaefer. David Schaefer, everybody. Thanks, guys. Does anybody have any questions? We have these these extraction gods here. If anybody wants to know more about whatever's in there, yes.
Well, there's a variety of things you can do. I like to be able to run it through reverse osmosis. I like to be able to control the pH, and I like to be able to run it through UV to clear out any sort of bacteria that could be potential. So there's beautiful RO systems with UV lights that you can set up to pH systems where you can control and dial in the pH to whatever you like, and that's they can be fairly expensive for large scale. You know, a lot of greenhouses use them for pepper and cucumber production, but it will be no different for cannabis. The unit that I'm looking at for our lab is probably close to $500,000.
And how effective is that RO on fluoride? My background is in dentistry, and I understand that fluoride is an extremely small molecule and extremely difficult to remove from the water.
Absolutely, it is. It's best if you can find water that's just never had it added to it. Absolutely.
Cool. Well, I have a question. Yes. So, can you create a way of taking weed and shrooms and making it into one product, like doing what you're doing, like extraction and psycho?
Weed and shrooms?
Yeah. Can you make it into one product by extracting from?
Yeah, I mean, you could do some different processes on extracting psilocybin and psilocin, and you could extract the cannabinoids and terpenes, and I guess you could mix them together in that sense. I would still do the extraction processes separate. I wouldn't put the herb and the mushrooms together. What about yourself, Dave?
I mean, you can extract two things separately and mix them together to make all sorts of different entourage effects, I'm sure. But as far as putting them together, you know, you can kind of mix anything together.
So, are there other things that you can mix with this weed that when you're extracting it that makes it better?
That makes it better?
Like it enhances your high because I've extracted from like the marijuana plant, but I've also extracted from like the mint plant, for example.
There's right now, I think there's a lot of salves out there used to, you know, there's a lot of different companies making mixtures of different things to where when you put them on your skin, they have the cannabis aspects, but also using other essential oils and other things with different properties to, you know, like heal muscle pain and loosen up muscles. So I think the biggest space that we're seeing cannabis products mixed together is in the salves and working on things like inflammation and muscle pain. That's where I see the most things. And right now it's just primarily been other essential oils and things that you'd see in, you know, like organic products that are good for reducing inflammation and muscle pain. So that's where I see that happening most. But in the U.S., there was a few companies that tried to take cannabis terpenes and mix them with alcohol, but the U.S. is very sensitive about mixing anything with alcohol whatsoever. So that project was pushed to the side, and now they're mixing the terpenes with water. Just because alcohol itself is, whenever you take different products and mix them together, you're creating a whole new kind of effect, like you're saying. So you have to be kind of careful with that. And the regulations definitely force people to be careful with mixing different types of products together like that. But in salves, I think, is where we're seeing cannabis mixed with other things to create an entourage effect besides the cannabis itself.
Hey guys, I've heard a lot of people say things like, "Well, this crop didn't turn out so well, so I'm just going to run it." Can you speak to the importance of using good flower and what you're looking for in a product that you want to use to make concentrates, as opposed to people just trying to save a batch of bad flower?
So I think there's a lot to be said about saving a batch of bad flower. It depends on what was bad about it. The remediation processes that are getting better and better, I think That's an extremely viable and valid place to use solvent extraction, is to take bad plant material, if you will, and when done 100% correctly and test it to the parts per billion, there are some situations to where a crop may not be the best crop depending on what was going on with it, that you can actually make a viable product that's safe and clean. But that's been a new space where I actually see it happening, to where I can actually say that, this is a viable process. This has been cleaned 100% correctly. But it's a very shaky road to go down, and without amazing lab testing, you really don't know where you stand. But there's a great future in that aspect of it. But I see this as part of the growing process of the industry. I don't, as people get better and better and move and progress forward, we'll see less and less of that, especially in the legal market.
Sorry, I have one more question. Is there a form of extraction of cannabis that makes the cannabis extraction last the longest?
Oh, that's a great point. I haven't seen. Do you want to go on that, Mark?
I mean, what we do as extractors is we unveil quality. We don't produce quality. We unveil it. So the quality is either there or it's not there. That's done by the genetics.
I think she's talking about shelf life, though.
Shelf life of the.
Like, because you talk about like a water version of extraction, and you talk about another type of extraction. So I'm saying, from all these types of extractions, which one is going to make my product last the longest, regardless of the quality initially?
Last the longest, as in shelf life?
Yeah.
100% solvent extraction on that one.
Yeah, or removing the oxygen and replacing it with nitrogen can increase shelf life like a lot.
I've seen that.
A lot. This has been used in the. No, it doesn't ruin the product. It just keeps oxidization.
So the big
occurring.
thing is the solvent extraction is actually going to remove most of the water, and that's a big aspect of degradation. That and oxygen content within the extract itself. So,
right, which we just do with freeze dryers. We just freeze dry the material and get like 100% of the water out. So.
But when you compare like a mechanical and rosin type of extraction, the shelf life is considerably less than like a hydrocarbon extraction, 100%.
I'm more focused on producing a product that you don't want to keep for a long time because you smoked it in the first day that you got it.
I still have BHO from years past that is still at the same quality as the day that I put it away.
Yeah, my oldest hash is 12 years old right now.
Seriously? So would it still get you high?
Oh, yeah. In fact, I have resin here, not here on me, but here in Toronto, that's 6 years old, and it was louder than probably 80% of the stuff I saw yesterday. Every single person that smelled it just went, wow.
So hash in general has a long shelf life?
It can, absolutely. It just depends on how you store it, right? You want to keep it out of the light. You want to keep oxygen away. If you cool it, if you keep it in a freezer or a fridge, you're going to extend the life cycle infinitely almost.
That's very good to know. Cool. Well, thanks, guys. Thanks.